This is SpaceTime, Series 27, Episode 133, for broadcast on the 4th of November 2024. Coming up on SpaceTime, new studies showing the Earth's mantle is actually composed of two different and very separate blobs of materials, China planning to host its first manned mission to the Moon by 2030, and NASA's SpaceX Crew 8 astronauts return to Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has discovered that the Earth's mantle is actually composed of two different and very separate types of materials, resulting in independent African and Pacific domains. The new data shows that the rocks sourced from the Earth's mantle are linked to the formation and breakup of supercontinents and superoceans over the past 700 million years, resulting in the planet having two distinct faces. The findings, reported in the journal Nature Geoscience, examine the chemical and isotopic makeup of rocks sourced from thousands of kilometres below the planet's surface to better understand how the Earth's mantle responds to plate movements that occur near its surface. The study's lead author, Luc-Serge Doucet from Curtin-university, says the Earth's mantle is currently divided into two main domains, African and Pacific, but little is known about their formation and history, and they're commonly assumed to be chemically the same. Doucet and colleagues use trace metals such as lead, strontium and neodymium from hotspot volcano islands, including the Hawaiian Islands in the Pacific Ocean and the La Réunion Island in the Indian Ocean, to examine whether these two domains have the same chemical makeup. They found that the African domain was enriched by subducted continental materials, which were linked to the assembly and breakup of the supercontinent Pangaea, whereas no such feature was found in the Pacific domain. So, that means the continents of the two mantle domains are not exactly the same as previously thought. Instead, the Earth appears to have two chemically very distinct hemispheric faces, with the Pacific Ring of Fire being the surface expression of the boundary between the two. The two chemically distinct hemispheres can best be explained by the distinct evolutionary histories of the two mantle domains during the Rodinia to Pangaea supercontinent cycles. The authors found that the African mantle domain contains continental materials which were brought down by the subduction system for at least the past 600 million years. However, the Pacific domain has been protected from the infiltration of such materials. The findings are significant because they show a dynamic relationship between plate tectonic processes that operate near the surface and the formation and evolution of Earth's deep mantle structures. So, this work helps scientists better understand what drives plate tectonics and the formation and reservation of global geotectonic features such as the Pacific Ring of Fire. Doucet says the dynamic and interactive nature of the entire Earth system has important implications for the formation of Earth resources, the evolution of Earth's environment, and even the evolution of life itself.
The research comes from the fact that when we look at the Earth, and so we know we have the crust, and then below the crust we have the mantle, and below the mantle at the center of the Earth we have the core, right? And it's very difficult to access the mantle because it's so far away, like very, very deep below the crust. And so we use indirect methods to image or understand what the mantle is about. So we use seismic imaging or tomography, which is basically a way to do like MRI the mantle. And when you look at the mantle, we find those massive structures below the mantle at the core mantle boundary, one below Africa and one below the Pacific. And those guys are called the large shared velocity provinces, or LLSVPs. So we have a colleague in over east, Nicolas Flamand, he wants to call them blobs because first it's funnier and also more easy to understand. So we have those giant blobs below the mantle, and we just want to understand why the structure of the mantle is so complex and so heterogeneous. And so, interestingly, those blobs basically control how the mantle is convecting. To give an idea, basically, this is above those LLSVPs that we can have like the mid-ocean ridges, or basically where the plates will just like separate from each other. And in between them, we're going to have like where the plate is going back to the mantle. So basically, if you look at the Earth, we have those giant blobs, and in between we have the Pacific Ring of Fire, which is basically the subduction zones going down and producing all the volcanoes. And the general idea was to understand if those structures have been there forever, or if they are moving through time, and how they are connecting to the continent, and especially where the continent move. So that was the main topic, because there is basically, until a couple of years ago, there is like basically two schools of thought saying that those structures stay there forever, and another school of thought saying that, oh no, they have to move, they have to be related to what's going on to the surface, because Earth is a like integrated system and everything is interconnected. So one way to test that would be to look at the rocks that would be generated because of those blobs, right? And if you look at the blobs, they are the main source, or actually they control the location where we're going to have the hotspot volcanoes. So like Hawaii, Iceland, La Réunion, we name it. But they also control where you have the mid-ocean ridges where we produce the oceanic crust. So one idea was saying, if the two mantle domains, which each contain the blobs, are the same, they should have the same composition. Because when you melt the mantle, you're going to produce the crust, but the composition of the crust will reflect the composition of the mantle. And so that's basically what we did. So we went to the databases, look at the composition of the oceanic crust, the composition of all the intraplanetary volcanoes we can find on the ocean, and then we compare the compositions using machine learning to see if the machine could see a difference between the two domains. And boom, we can find that they are different in composition. So if they are different in composition, meaning they must be explained by something, why they're different. And the best way we find to explain them, if you look at the structure, we see that we have an African blob, which sits basically below all the continental hemisphere, which once again, once upon a time was Pangaea, while the other blob just sits below the Pacific, and back in the day was just like the super ocean of the planet when we have Pangaea. So we have Pangaea one side with its own blob, and we had the Pacific blob, which were just the super ocean. And say, oh, interesting that there are chemical differences between the two, and how we can explain that. And again, just looking at geology and looking at the past of how you form supercontinent, we know that when you form supercontinent, you need to bring plates together. And when the best way to do that is having subduction zones that basically have like plates going down back to the mantle and basically attracting two different plates together and smashing them together. But when you do that, you basically put a lot of sediments into the ocean basins, and all the sediments will go back in the mantle during the subduction zone or during the collisions. And very interestingly, when you look at the composition of the basalts and the oceanic crust from the African domain compared to the Pacific domain, you see that the African domain, which is the continental hemisphere where Pangaea was, it's more enriched in continental elements. That's how we can say that, oh, maybe our theory like hold the water, because we could explain the composition by the formation of the last supercontinent, Pangaea.
Is this in tension with the other hypothesis at the moment, which is that the mantle is uniform and the only chemical changes that really occur are as magma rises up from the mantle and passes through volcanoes on the way to the surface?
Yes. So there is this but the thing is, when we overall, that's what's happening, because the volcanic processes, the magmatic processes control a lot of the composition. The thing we have is when you look at rock that go through the same processes. So we look at the oceanic crust that basically just experience melting and emplacements in the crust. And when you compare the rock that went to the same processes, volcanic processes in the Pacific or in the African domain, so basically they form in the same way, they still have different geochemical compositions. So we tried in the study to compare what's comparable, because you're right, if you have a rock forming in a different way, maybe they can have a different composition just based on the fact that they form in a different way. But in our case, we focus on rocks that form in exactly the same, not really exactly, but in very similar way.
So in a way, the Earth has two faces.
Yes, exactly. So in that case, it means that the mantle that stores those rocks has different compositions. Overall, they are overall different. And that's what's fascinating, is because for a long time we thought, as you said, that the mantle was homogeneous, or at least part was homogeneous, and the molds, the mid-ocean ridges, basalt, the rocks we studied, were very homogeneous, and we can use that to make models about how they have evolved. But if they are very different, then we need to take that into account to understand how the planet evolved.
Where would you like to take this next?
So next is really cool. Next is basically, now we have mapped out basically what's going on today, so looking at the present day composition, and then we want to go back in time. So to do that, we need to look at oceolites, which are fragments of oceanic crust in place in continent during the formation of the supercontinent, for example. And we have a PhD student that working on this and find very interesting results. And also another thing we want to do is do geodynamic modeling. So basically reproduce how the Earth mantle and the crust move for the last billion or 2 billion years. Try to map out those mantle domains through time to see if the mantle domain today results from one cycle or two cycle or three cycle, which is something we still don't know yet.
Yeah, because it's not just one supercontinent that existed before. The continent broke up and subducted and came back up. Yes. There have been several cycles like this, and you'd think there would be some sort of chemical history of that.
Exactly. So that's exactly the case. So what we see is like We have a strong imprint on the mantle from the last supercontinent cycles, but there is still, if you look into the detail of the composition of all the islands and the oceanic crust, we see patches of things that are a bit different, and that doesn't necessarily match this hypothesis. Even though at first order it works, at second order we see some problems, and maybe those problems rely on the previous cycles, the before Pangea. So when we had Rodinia, or even the previous supercontinent when we had Nuna. That's things that are not resolved yet, and that's things we want to understand better.
All this has implications for how life developed on Earth too, doesn't it?
So that's one of the aspects is when you enrich the mantle, when you do that by subduction, you bring continental material back to the mantle, especially sediments, and some of the sediments, they are carbon rich. So the carbonates, for example, that form at the continental margin, if they're being subducted at some point, you're going to bring a lot of CO2 in the mantle. But if what you're saying is true, it means that you enrich the mantle in some ways, in some places more than other places. So when you have volcanism, maybe you're going to release more carbon or more other volatiles locally, and that might have an impact on the local climate or local development of life. So that's one aspect we try to understand as well. One question would be how confident we are in being able to map out, like after before Pangea, I would say very difficult. But something that's really exciting is there is a huge leap in technology, especially when we're using machine learning to understand reconstruction of supercontinents, because there are still models, and there are several models, but if we can link the geodynamic modeling, the geochemistry, and the supercontinent cycles models we have now, we're going to make huge progress, and the technology will probably help us, and that's very exciting.
That's Luc Serge-Dessay from Curtin-university. And this is SpaceTime. Still to come, China planning to undertake its first manned mission to the moon before 2030. And after 7 months aboard the International Space Station, NASA's SpaceX Crew 8 have returned to Earth, safely splashing down off the coast of Florida. All that and more still to come on SpaceTime. China has announced plans to have its first Taikonauts walking on the moon before 2030. Beijing says it's accelerating its mission plans following substantial progress in the development, testing and construction of infrastructure associated with the program. The China Manned Space Agency's strategy involves deploying its new Super Heavy Lift Long March 10 three-stage rocket to separately deliver the manned Mengzhu or Dream Vessel spacecraft, which will carry 3 Taikonauts from the Earth to lunar orbit, and the Langyu or Embracing the Moon manned lunar lander, which will transport 2 of those Taikonauts down to the lunar surface. The 2 spacecraft will rendezvous in lunar orbit, with crews then transferring from one vehicle to the other. Prototypes of the new Long March 10 are already in production, with ground test validation underway and the first test flight slated for 2027. Beijing claims the new 93-metre-tall rocket will be able to transport up to 70 tonnes into low Earth orbit and 27 tonnes into translunar orbit. A new launch complex for the Long March 10 is also being developed, as are specialised dedicated ground stations for communications, telemetry and mission control. As well as the lunar missions, the 21.6-ton reusable Mengzhu spacecraft will also replace the current Russian Soyuz-based Shenzhou capsules on low Earth orbit flights to China's space station. Beijing says it's already undertaken integrated airdrop tests to validate the Mengzhu's performance. Meanwhile, we now know the Langyu lunar lander will consist of separate descent and ascent stages. That's really similar in concept to the Apollo lunar modules of the 1960s and 70s. Beijing's also developing a lunar rover. That'll allow Taikonauts to cover a greater area of terrain once they arrive on the moon's surface. Like the NASA-led Artemis mission, China's looking at a landing site near the lunar South Pole. And Beijing's also working with Russia to develop a new joint manned space base on the lunar surface, which should be operational during the early 2030s. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, NASA's SpaceX Crew 8 returns safely to Earth, splashing down off the coast of Florida. And later in the Science Report, Australia's weather and climate continues to change, with more extreme heat events and extended fire seasons. All that and more still to come on SpaceTime. Well, after 7 months in orbit aboard the International Space Station, NASA's SpaceX Crew 8 have finally returned back to Earth, safely splashing down off the coast of Florida. During their mission on station, the 4 crew members carried out more than 200 scientific investigations. These included demonstrating space-based manufacturing and production processes, such as the in-space development of stem cells, which can then be matured into a wide variety of tissues. These could then be used for future large-scale in-space biomanufacturing of stem cell-derived products, which could then be used for new treatments for heart diseases, neurodegenerative issues, and other conditions. Other studies were dedicated to crystallizing organic molecules in microgravity, an environment that alters many observable phenomena, thereby allowing scientists to study things in ways simply not possible on Earth. The crew also supported the third experiment in a series of products to improve ultra-sensitive biosensors. These can be used to detect trace substances in liquids, including early cancer biomarkers. By using laser heating to control bubble formation in microgravity, they improved particle collection, a key step in boosting sensor sensitivity. Other research tested a new ultra-high-resolution single-sensor camera, validating the camera's function, operations, and video downlink capabilities in microgravity. Crew 8 astronauts also investigated the effects of radiation in the space environment on mechanisms for gene editing. Those results could help develop new ways to better protect astronauts and shed light on genetic risk factors for certain diseases during spaceflight. Another investigation looked at how plants grow at different orbital altitudes. The results of this could provide new insights into the production of crops for long-duration missions in high radiation environments.
We can see Crew 8 being joyfully welcomed aboard the International Space Station.
It's just great to be back. There's such a sense of familiarity and homeness to the station. Can't wait to get back to work. I know that our flight's going to go by in a blink of an eye, and really anxious to start.
It's pretty cool up here that our work is fun and it's fun to work. Our daily schedule is awesome to me because it's different every single day. For example, today I got to put together a launcher that's going to launch satellites in a couple days. It's going to launch little baby satellites out into space. Tomorrow I might be doing experiments, all kinds of crazy things. And then I get to go look out the window and take pictures, so it's pretty awesome.
Research is constantly changing. It's never the same thing. Like, we have transparent alloys that we're working on, a lot of DNA sequencing. But for me, one of the things that I've been a part of from the beginning is the immunity assay, so that we can look at our immunity function while we're on board the station.
The ISS is an incredibly well-equipped laboratory, and we are testing everything up here from the life support systems to exercise countermeasures, but also the ability to do science.
Mike Huntsville on 3, we're liking the way it looks from this angle.
Copy that. This is really nice hardware to work with.
We are the hands and the eyes of all the researchers on the Earth. The other day I was working on something called the Code Atom Lab, where we can take materials and different particles and we can cool them down to some of the coolest temperatures in the universe.
So many nations work together to put together this International Space Station. I love the space station and I love being on Earth. When you look out these windows and you look at Earth, it just blows you away with its beauty.
This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The 2024 State of the Climate Report has been issued, finding Australia's weather and climatic patterns have continued to change, with more extreme heat events, longer fire seasons, more intense heavy rainfall, and rising sea levels. The CSIRO and the Bureau of Meteorology produce these reports once every 2 years. They're designed to assess changes and long-term trends in Australia's climate and weather. The report found that greenhouse gases in the atmosphere are continuing to increase, and 8 of the 9 warmest years on record in Australia have occurred since 2013. All this has led to an increase in extreme fire weather and longer fire seasons across large parts of the country. Reduced rainfall in southwestern Australia between April and October is now likely to become a permanent feature of the local climate. At the same time, heavy rainfall events are becoming more intense, especially in the north of the country. Oceans around Australia are also continuing to warm, contributing to longer and more frequent heat waves and coral bleaching. And the oceans are also becoming more acidic, especially in parts of southern Australia. Rates of sea level rise continue to vary across the country, with the largest increases in the north and southeast of the Australian continent. There was some good news, with Australian greenhouse emissions declining since 2005. However, because of global implications, the warming is projected to continue to increase over coming decades. The World Meteorological Organization says China remains the world's biggest carbon dioxide polluter, producing more than a third of the total global output. That amounts to more than 10.2 million tonnes annually. That's about double that of the United States, which is the second worst polluter on the planet, and 4 times that of India, which holds third place. They're followed by Russia, Japan, Iran, Germany, Saudi Arabia, Indonesia and South Korea in 10th place. Next comes Canada, then Brazil, Turkey, South Africa, Mexico, Australia is in 16th place. It's followed by the United Kingdom, Italy, Poland and Vietnam, rounding off the worst 20. A new study claims vitamin K2 could help avoid painful leg cramps at night. The findings, reported in the Journal of the American Medical Association, are based on a trial of people aged over 65. Some 200 people with regular night cramps participated in the trial. They were monitored for 2 weeks before the trial commenced in order to assess how frequently they had leg cramps. Half were then given vitamin K2 supplements for 8 weeks, while the remainder were given a placebo. The authors found that while both groups had the same average frequency of cramps before they were given the supplements, those in the vitamin K2 group on average had fewer cramps and of lower severity and duration compared to the placebo group over the 8-week trial period. The Australian Defence Force has taken delivery of the first of 40 new next-generation Black Hawk helicopters from the United States under a $3 billion deal. At the same time, the ADF has also confirmed a new $21 billion contract to ramp up local guided missile production. The new projects come in the shadow of growing regional aggression by China, raising concerns among Pacific Island and Asian nations. The new missile deal will see an increase in domestic missile and munitions manufacturing, including the development of a new long-range strike capability. The project includes a new plant for manufacturing 155mm M795 artillery ammunition. The announcement comes just a week after Australia confirmed plans to purchase $7 billion worth of American Standard Missile Block 3Cs and Standard Missile 6s. And of course there's last month's announcement of a new guided missile manufacturing plant to be built near Newcastle in New South Wales. The new long-range strike capabilities will improve the range of Australian weaponry from 200 kilometres to more than 2,500. Meanwhile, the Army's just taken delivery of the first 10 U-860M Black Hawk helicopters in a move which will see the return of what was once a trusted warhorse. At the same time, it'll bring a long-awaited end to the fiasco of the often grounded Taipan fleet. The $3 billion contract with Lockheed Martin will see 40 of the choppers enter service by later next year. Meanwhile, the disposal of Australia's 46 grounded MRH-90 Taipans, which Ukraine tried unsuccessfully to acquire, should be complete by the end of this year. In January 2021, the ADF announced plans to replace its aging Tiger attack helicopters with 29 new Apache A864Es, and that's a recommendation that this program made to the then Defence Minister more than 10 years ago. Pity they didn't listen. A new documentary has been released looking at a failed attempt to produce a movie about Point Pleasant's infamous Mothman monster. The doco, Mothman, the film that never was, explains why the Mothman movie was never completed. Now, this is not to be confused with the 2002 movie The Mothman Prophecy starring Richard Gere. Filming for the unfinished Mothman movie dates back to 1997. Tim Mendham from Australian Skeptic says the new documentary includes never-before-seen footage from the Mothman movie and lets listeners hear first-hand accounts from the cast and crew during the filming of the original movie.
I trying to think how long Mothman has been around. I think every place needs to have its monster of some sort, whether it's a lake monster or whether it's something in the forest. The Jersey Devil was apparently made up by a real estate agent, believe it or not. It's a deer standing up on its hind legs eating stuff, as deers do. But yeah, apparently it was made up by a real estate agent to try and get some interest in an area. Anyway, Mothman, I'm not quite sure what the antecedents of Mothman are. It's been around for a little while. There's a story recently, there's a film released called Mothman, the Film That Never Was. Mothman is supposed to be this sort of large, humanoid, muscly sort of figure that looks like a moth. It has wings most of the time. It has glowing eyes. Yeah, okay, thank you. A barn owl. It has glowing eyes, of course. All these things have glowing eyes. And it does terrible things. Now, I'm not quite sure about the bridge collapse. I think that came from the film The Mothman Prophecies. Anyway, but yeah, there was this film made called the Mothman, the Film That Never Was. There was going to be a film of Mothman made in the town of Point Pleasant in West Virginia. Point Pleasant is a place where there's a lot of Mothman sightings, and they're going to make a film about Mothman, not the one with Richard Gere, but a different one. And they were all going ahead, and a lot of the residents were having a good time, excited to be playing extras, etc. And suddenly a handful of Point Pleasant residents who did not want this to happen started threatening the crew members, and they were worried about their personal safety. And because the area around Point Pleasant supposedly had rumoured ties to organised crime, and so if that was the case, there's organised criminals who didn't exactly want a lot of publicity about their area because they would interfere with their activities. So this film that was going to be made was stopped halfway through because the crew got threatened and everyone got a bit worried. So that was in the late 90s. So someone now has made a documentary about the film that wasn't made, and he's showing it at Point Pleasant in the Mothman Festival. So Point Pleasant has changed from being criminal-based, frightening people off, to actually embracing the Mothman legend. So they've got a Mothman museum and all sorts of stuff. So Point Pleasant is now your Mothman venue of choice. It's one of these classic sort of monsters that builds up and up and up in reputation as time goes on.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.